So, we're going to be using angle relationships for two main purposes. First is just finding the measure of missing angles. And the second will be proving that lines are parallel. I've actually already talked about that a little bit. Our notes started with justifying that lines are parallel based on angle relationships. We're going to get into more thorough proofs in a little bit. These notes are really just about finding the measure of missing angles, really just this first purpose. So here we're given that angle 12 has a measure of 121 degrees. Actually, I'm going to label that. Angle 12 is 121 degrees. Angle 6 is 75 degrees. We're going to find all of these missing angles just using those two numbers and the fact that these two lines are parallel. All right, so first one I see clearest is any vertical angle. So directly across from angle 6, I see angle 1. That has to be the same. Vertical angles are the same. We don't even need the parallel lines for that, but I know that angle 1 has to be the same as the angle across from it. This slice and this slice are the same, so they're both 75 degrees. Same thing here. Angle 7 is the same as angle 12, so that's 121. Now I have some supplementary angles at this bottom intersection here. These two angles, this angle. Actually, I should really be marking these with different curves. So if this has 1, this has 1. If this has 2, this should have 2. This is going to get pretty messy pretty fast. If this has 3, this should have 3. I don't know if I'm going to keep marking all of them. I might just label them with their measures because that's going to get pretty crazy. You might also see this written in a different way. Sometimes they mark it with an angle with that arc and then put one line over top of it or two lines. There's a few different ways you can mark that. Really, as long as they have the same arc there, that means they have the same measure. I know that these are vertical, so they're going to be the same. And I know that these two are forming a straight line. So they add up to 180, so that has to be 59. 180 minus 121 is 59. So angles 11 and 8 are both 59 degrees. All right, next I'm going to use my corresponding angles. Again, these two lines are parallel, so that means corresponding angles have to be the same. Angle 8 and angle 3 are corresponding angles. I'm going to erase everything I have so far just to clean this up. And I just want to highlight angle 8, and then following along the transversal in the exact same position is angle 3. We have these two lines that are parallel, and this transversal cuts across them, meaning corresponding angles have to be the same. So if angle 8 is 59, so is angle 3, and so is angle 4. You can see this two different ways. First off, those are vertical, or this angle and this angle are alternate interior angles, so they have to be the same also. Now I'm going to use that line at the top. I just have a straight line cutting across here. So this angle, and this angle, all together, that has to add up to 180. So angle 2 has to be 46 degrees. 180 minus that, and that leaves us with 46 degrees. And angle 5 has to be the same. Again, those are vertical angles, so they have to be the same. So angle 5 is also 46 degrees. All right, now I'm going to have to use my parallel lines again to get down to this intersection. I'm going to clean this up one more time. I'm going to use this angle. That's 75 degrees. That corresponds with angle 9 down here. We have this transversal that cuts across these two parallel lines. These are in the exact same position. They have to be the same. Those are called corresponding angles. So angle 9 is 75 degrees, and so is angle 14 because those are alternate exterior angles. You probably also see this. These are vertical, but I just want you using parallel lines. I just want to point it out at least that you could see it. Angle 14 and angle 1 are on opposite sides of the transversal, so they're alternate, and they're outside the parallel line, so they're exterior. Those are alternate exterior angles, so they have to be the same. Now we're just going to use supplementary angles. If this is 75, and we know that these two together have to add up to 180, that has to be 105. And so does that. So you can see it looks complicated at first, but once you start finding one angle, it makes it a lot easier to find the rest of them. example 2, we're told that the measure of angle 7 is 38 degrees. The measure of angle 10 is 102. We have two parallel lines. These two are parallel, and we're trying to find all these missing angles. So these two, I just want to point this out, angle 7 and angle 3. Those are corresponding angles, but they're not congruent because these two lines are not parallel. You can see that those are not going to be the same. They're still called corresponding angles, but since we don't have parallel lines, they're not congruent. However, going across to here, following this transversal, 15 and 7 are corresponding angles that are congruent because these two lines are parallel. They're in the same position along the transversal that cuts across those two parallel lines. So those have to be the same. So angle 15 is also 38. Angle 5 is also 38, so is angle 13 because those are vertical and those are vertical. So that's 13 and 5. I'm just going to stick with the bottom right now because I have supplementary angles. So I know that this angle and this angle put together, they have to add up to 180. So that's got to be 142 because those two add up to 180. Angle 8, 6, 16, and 14 all have to be the same. Those are all 142. These angles are not going to be helpful for any of these angles. Again, those two lines are not parallel, so we can't conclude anything based off of those at the bottom, but we can use angle 10 as 102 to help us find all of those missing angles. So angle 10 and angle 12 are vertical. They have to be the same. Angle 10 and angle 2 are corresponding. They have to be the same. Angle 10 and angle 4 are alternate exterior angles. They're on the opposite side of the transversal. That's where the word alternate comes from. They're on the opposite side of the transversal. And they're outside the parallel lines. That's where the word exterior comes from. They're alternate exterior angles. All of those have to be the same. So 2, 4, 10, and 12 are all 102 degrees. Angle 9 and angle 10 are supplementary. So 9, along with these other 3, have to be 78. That last step might have been a little too fast. If this is 78, this is 78 because those are vertical. This angle and this angle with angle 1 and angle 9, those are corresponding. They have to be the same. And then these are corresponding. This is also an alternate interior angle with angle 3. So we know those have to be the same also. All right, on the last one, angle 2 is 41. Angle 5 is 94. Angle 10 is 109. Sometimes you're going to look at a picture and really not going to know where to start. Try to find whatever you can. First one I'm noticing is angle 4. I see that those two angles together, they make this straight line. So those are supplementary. They have to add up to 180. So angle 4 will be 86. I don't know if I can find anything else directly without using these parallel lines. Doesn't look like I can. So now I have to use the fact that these two lines are parallel. I see that angle 4 corresponds, corresponds with angle 1. These two parallel lines are cut by that transversal, and angles 1 and 4 are in the exact same position. So they have to be the same. So angle 1 is also 86. Let's find angle 3 here. I see that these are making a straight line together, so they add up to 180 altogether. So that's 127. So that's 53 left over. 3. All of those together have to add up to 180. So angle 3 is 53 degrees. I won't be able to jump from any of these three to either of these two because this line and this line are not parallel. I'm going to need to use angle 10 because this line is parallel to that line. And it's cut by this, these two lines are cut by that transversal. That is cutting across these two parallel lines, which means this angle and this angle are corresponding angles. And they're congruent because we have parallel lines. So that is 109 degrees. This is going to be 71 because together they add up to 180. They are supplementary. And then we know that these two together are going to be 71. So we know angle 8 plus angle 9 equals 71 degrees. We can't directly find out what either of those are. Actually, this is getting a step ahead of ourselves. Really, we need to use a fact about triangles. The interior angles of triangles, this angle, and this angle. The inside angles of this triangle have to add up to 180. We found out that angle 7 is 109, angle 2 is 41. So angle 8 has to be the rest of that 180. 180 minus 109 minus 41 gives us leftover amount of 30. So angle 8 has to be 30. And we know that these two add up to 71 because they're corresponding with angle 6. So the leftover part there has to be 41 degrees. All right, try that one problem on your own here. And then we're going to move on to a little bit more complicated problem solving where we need to set up an equation instead of just directly solving for an angle. So first off, the angle pair relationship will always determine the equation that we set up. These are really just reminders. Complementary angles have a sum of 90 degrees. Supplementary have a sum of 180. Vertical angles are congruent. When we have two parallel lines and they're crossed by a third line, the corresponding angles are congruent. Alternate interior, alternate exterior angles are also congruent. And then consecutive interior angles and consecutive exterior angles are supplementary. Each of these is going to tell us exactly how to set up our equation for each picture. So first you want to just identify what's the relationship between those two angles. We want to solve for x. So this angle and this angle. Those are called vertical angles, so we know that they're congruent, or they're equal to each other. So I can set those two expressions equal to each other. 2x plus 30 equals 7x minus 25. This equation comes from the angle relationship. I know that those two angles are congruent. I know they're equal to each other, so I could say this expression equals that expression, and then we're going to solve that equation. You can use Desmos if you like. I honestly think it's faster to just solve this by hand. You're going to subtract 2x from both sides, so you get 5x. We're going to add the 25 to the other side and get 55, and get that x is 11. Again, if that went too fast, use Desmos or review solving equations, but that kind of an equation should be pretty easy for us to solve. We're looking for the measure of each of these angles now. So this angle, and this angle, I see that together they're forming this straight line PQ. So those are called supplementary. Really, it's only referring to two, but all three of these we know are going to add up to 180. We only refer to two angles when we're talking about supplementary angles. Either way, my equation is coming from their total. 5x plus 4 plus x minus 2 plus 3x plus 7. All adds up to 180 degrees. I'm going to combine like terms. Get 9x plus 9 equals 180. So 171 divided by 9 is 19. So x is 19. Now we're looking for the measures of those angles. So I'm going to take that and plug that back in. SOP is this one. So I'm going to substitute 19 in and evaluate that expression. That's 95 plus 4 is 99 This one's a little bit easier. That's just 17, ROS. And then 57 plus 4 is 64. We just substituted that back in. All right, so sometimes you're going to have to solve for x, just like that. Sometimes you solve for x and substitute it back in to find the angles. All right, we're going to find the value of 11x minus 47. That angle and that angle are corresponding. We're missing some information here. These should be marked as parallel, or there should be some information saying L is parallel to M. But that's essential, otherwise we don't know that these are actually congruent. But now that I'm marking that, we can assume that these are congruent corresponding angles. So 11x minus 47, we know corresponding angles are congruent. That's where this equation is coming from. I know that they're equal to each other. So I'm going to combine like terms to either side and get that x is 9. I'm going to substitute that in. 99 minus 47 is 52. You can always just check to make sure that you did this right. If you substitute 9 in here, 54 minus 2 is also 52. These should be the same value because we know that they're congruent. An angle Q is a right angle. That means that has a measure of 90 degrees. Find the measure of the smallest angle. So looks like that one's going to be the smallest because we're subtracting from it. It's x plus 3, x minus 1, x plus 1. So we're going to find the measure of that angle once we solve for x. We know that together they add up to 90. They are forming a right angle. So 3x, sorry, I'm just combining like terms, 1x, 2x's, 3x's, plus 3, these guys cancel out, so plus 3 equals 90. So 3x equals 87, so x equals 29. This angle would be 30, this angle would be 28, this angle would be 32. Again, if something happened to go wrong here, you can check to make sure this should add up to 90. If for some reason, let's say by mistake you got 28, and you substitute that back in, you'll find out that that doesn't actually work. Those don't equal 90 when you substitute that back in. Smallest angle there is angle, sorry, not angle, it's just 28 degrees. All right, now we're gonna have two variables. So we're gonna need to figure out what we can solve for first and then use that variable to solve for the other one. Same missing information here, sorry. This should be marked that L is parallel to M, or on the picture, we should show that those are parallel. I see I have two x's, so I'm going to need to use those. The y I'll get to later. This angle and this angle. Those are not congruent. Those are supplementary because they're consecutive exterior angles. When I say consecutive, I just mean that they're on the same side of the transversal. That's the transversal. They're on the same side. Exterior means they're on the outside of the two parallel lines. I know that those are supplementary. So 18x minus 44 plus 8x plus 10, minus 10, equals 180. So 26x minus 54 equals 180. So 26x equals 234, and then we divide by 26 and get that x is 9. So now that I know that x is 9, I could substitute that back into this expression, and that'll help me solve for that angle. Actually, nope, that's the long way. I'm going to just substitute it in here. These are alternate exterior angles. This angle and this angle are alternate exterior, so they have to be the same. So if I substitute 9 in here, that'll directly tell me the measure of that missing angle. (18 times 9 is 162, minus 44 is 118. So this angle, 13y minus 38, has a measure of 118 degrees. Now I'm going to solve that equation. Add the 38 over and divide by 13, and get that y is 12. All right, I hope this helps. If you have any questions, ask.